The world as we know today is under a severe energy crisis. All our current energy sources, like fossil fuels and other non-renewable sources, are fast depleting. And as a result, it is imperative to conduct research and find other alternatives. And as a result, we humans have come up with many alternatives, namely solar energy, wind energy, etc. But as we know, these alternatives are not that viable or feasible. Either they're very costly, or they don't end up producing enough electricity. As a result, we guys have done some research in this field, and we'll be talking about it today. So, before I move on, I'd just like to talk about the video from where we got inspiration and actually got intrigued enough to go into this field. So we came up across this video on YouTube in which a person is making copper oxides at home and then doing a photoelectric experiment. So in that experiment, first we can see he prepares copper oxide in his kitchen stove and has placed them in a container to show us the impact. As it's pretty evident from the video, the level of sophistication is not enough, and being a YouTube video, we really doubted its authenticity, and we actually thought it might be a pseudo video. As a result, we thought if it's true, it might be of some good use, and as a result, we tried it ourselves. And so the aim we came up with in this process is as follows. So our aim was to study the effect of oxide coating on metal electrodes in photoelectrochemical cells across various concentrations of salt solutions, and to find the best setup in terms of concentration as well as the composition of electrodes. Now I'd like to pass on to Raghu, who will talk to you about the hypothesis and the apparatus.
So when we first sat down and discussed about the aim, we thought what all things should we expect from our experiment. So the first thing that we expected was that we expected that there would be some form of deflection in the ammeter which will show us that a photovoltaic effect is being exhibited here. And different combinations will obviously yield different results. And the one where oxide coating will be superior to that, will be superior to others. And then we saw that the apparatus in the video was a very crude nature. And the ammeter had a very bad least count, and so we replaced it with a multimeter which had a better least count. We used a thermometer, an electronic thermometer, to measure the temperature at equal intervals of time. We used alligator clips, metal plates, a glass trough, distilled water, NaCl, and a 20 watt CFL. So we use a glass trough instead of a plastic card bottle, so that our experiment is more it's more sophisticated. We use a 20 watt CFL to simulate sunlight, and we use it as an artificial light in our experiment. We use distilled water instead of tap water so that our experiment has more accurate readings, and we use lab grade NaCl. We use a digital thermometer and a multimeter. Now I'd like to pass on to Mahip, who will explain to us what procedure we use.
Moving on with the procedure. First we made salt, NaCl salt. We had to make solutions of different molarities. So we had set up different weights of salts on different plates. And then we put the salt which we had weighed, we mixed them in distilled water to make solutions of respective molarities we wanted. We had to select some metals for our experiment. We selected copper and zinc plates. We selected copper and zinc mainly because they are widely available and they are quite inexpensive also. So this is a picture of the setup. As you can see, we had dipped the electrodes in the solution which we had made with NaCl and distilled water. And we'll also put a thermometer inside so that we can check if the current is getting affected by this heat also. And now we tried out different combinations. So we took solutions of different molarities, and we also took different metal plates, like we took impure copper, impure zinc, and copper, and pure copper also. So we recorded we took the data in light as well as in the dark, so that we can conclude that there is a certain role played by light also. And after we had obtained certain graphs from a research which my teammates will be talking to you about later in this presentation, we came up with the best setup and we simulated it in sunlight to obtain our readings and graph data. So now Shaurya and Shivendra will be talking to you about the observations of our research.
Good morning again. So what we noted was that whenever we dipped the electrodes inside a salt solution, there was always a certain degree of current which was produced. And to show it in a better format, we compiled the readings into graphs, and these graphs we will be showing to you after this slide. So what we firstly did was that we took impure copper and copper. The same metal, because in a photoelectrochemical cell, you need to take the same metals so as to induce a reaction. So what we found out was that the readings were coming in microamperes. Now this was as a result completely inefficient and wasn't good enough to go forward into. So we were dissatisfied, but we decided to try different metals as anodes. So what we did was we took zinc as our new anode, and then we tried the same experiment, the same setup again. So the first combination you can see over here is with taking pure copper as cathode and impure zinc, the different metal, as anode. So what you can see is that as the molarity increases, so does the current in its degree. And what we can also observe is that when there is presence of light, there is a certain increase in the current which we noted even in the impure combination. Also another observation which we noted was that this combination, which was coated with oxide, an oxide layer on it, showed as a whole more readings on an average than the combination which was pure. So we also came up with this, that oxide coating shows increase in current. Now as to the first observation which we noted was that the sunlight was actually not increasing the current in a photoelectrochemical way, but there was another phenomenon which was taking place, and this phenomenon is known as galvanic corrosion. Now what galvanic corrosion is, when two dissimilar metals with different electrode potentials are taken in a salt solution, the one metal, the anode, which has a lower electrode potential, tends to corrode because of the electrochemical reaction which is taking place. So after all these slides, afterwards we will conclude that presence of sunlight at the end finally increases the rate of galvanic corrosion, due to which the current also increases by a 0.7% margin as seen over here as well as here. Now I would like to pass on the mic to Shaurya, who will be explaining on the further graphs.
So now, based on the previous experiment that we conducted in artificial light, we chose 4 different solutions on which we experimented upon in sunlight. First was with a molarity of 0.6, which is the green line right there, underneath the yellow of 0.8 and the blue of 1. Now we chose the molarity 0.6 because it produced the most effect of light in the experiment that we conducted in artificial light. Now, after the current had stabilized, we took our first reading, which was of a 9.97 which was of a rate of 9.97 milliamperes. Within the next 10 minutes, it dropped by 1.33 milliamperes. Therefore, it had about drop percentage of 13.3 milliamperes, which is pretty decent according to us. Now, next moving on, we experimented upon a solution with a molarity of 0.8, which is the yellow line right there next to the 10 milliampere mark. Now the initial value of the solution was 10, and it only dropped by 0.68 milliamperes, and it had a drop percentage of 6.8%. Also, the reason we chose this solution was because it produced the most amount of current in the experiment that we conducted in artificial light. Next, we experimented upon with molarity of 0.1 or molarity of 1, which we thought was actually an error when we conducted it in artificial light because it produced less current than the molarity 0.8. As it turns out, even in sunlight it produced less current, and it also had a drop of about 17% from its initial value, which was 9.60 milliamperes, and the drop was about 1.65 milliamperes. Finally, we tested a saturated solution, which is the red light on top,
which produce the maximum amount of current, like we hypothesized earlier. And its initial value was 24.9, which was the maximum, but its drop was also but it also had a drastic drop of 6.1 milliamperes, which was of a drop percentage of 24.5 milliamperes. And as you can see on the side, the highlights of this experiment was that 0.8 molarity was the most would produce the most stable current, and the maximum current was produced with a saturated solution. Now I shall pass on the mic to Chaitanya, who will be summarizing all the observations.
So the conclusions we came up with after all the observations we made are the following. The best combination for this experiment is going to be pure zinc as anode and impure copper as our cathode. The most effect of light was on 0.6 molarity. That is, it resulted in the maximum current in milliamperes, and 0.8 was the most stable after saturated solution in terms of current production. But being saturated, as our major concern was having a viable and effective alternative, we actually discarded the use of saturated solution because a lot of salt went into its production. That is about, the concentration was around 3.7 moles per liter. So that means that resulted in a lot of salt usage. And the most consistent molarity in sunlight was 1.0 moles, and hence all these best combinations we've come up with will be can be taken as an alternative for solar power production. Of course, compared to the normal silicon solar cells that are used, this solar cell is of course not as efficient and as effective. But in regions where these solar cells are not available or are not viable to keep, because they might be costly to people, especially people living in the hills, let's say, we can use this as an alternative for electricity production. Now this can also be used, as we use salt water throughout, we thought this could be used for electricity generation using salt water as well. So we had the following limitations in our experiment. First, the temperature could not be kept constant, although we monitored it. Of course, there are having very sharp changes in temperature, especially afternoons, because we conducted our experiment after classes and during the game time, because that's when the temperature actually decreased drastically. And zinc could not be kept in a pure state as it has high affinity for oxygen. And as a result, all the time and every time we use zinc, we ended up using zinc oxide. So the future scope will be talked about by Raghav. Thank you. So sorry, Shivendra will talk about the future scope.
Now, actually, as I explained to you earlier as well, there was the phenomenon of galvanic corrosion due to which this current was being produced. So what we noticed was that the rate of galvanic corrosion in steel and other metallic structures, buildings, all get enhanced in the presence of sunlight. Now what happens is that whenever the sunlight hits the anode and the cathode, basically the electrodes, what happens is this process of the corrosion of anode takes place at a faster rate. So when these similar metals which are present in the buildings, when they're exposed to sunlight, actually this corrosion is happening at a much faster rate. And what we've come up with to actually inculcate this in building purposes in the future is that we should have a protective sunlight cover on the buildings so that we can prevent the corrosion by even if a small margin, but we can prevent it to some measure. Next slide please. And the next thing was that almost all of the structures, the vehicles and the boats are made out of metals. And what happens is that in some cases this corrosion is encouraged. Or what we can see over here, these are the hulls of two boats, and on the screws we have actually put up an anode which is corroding instead of the metal surface around it. So this is preventing the corrosion of the metal surface by actually sacrificing the anode, which we can see has corroded over here. Also in this case, all these metal bars, they're covered with a sacrificial anode, what we call, mostly made up of zinc, and this instead gets corroded rather than the metal bars which surround it. So we actually plan to prevent sunlight from being incident on the surface, because as you know and as I have explained, sunlight actually increases the rate of corrosion. So if we cover it, the rate of galvanic corrosion will decrease, and therefore the construction can be more productive and can last for a longer time. Also, we won't have to replace these sacrificial anodes, and they can be more consistent and could last for a longer time as well.
So we use the following sources in our research. You can have a look at that. And we like to give special thanks to few teachers and especially the lab assistants who helped us throughout this process. Thank you.
So actually, because I think this is something about new material and I'm very keen about that, so I start to record during presentation to look at it.
Yeah.
Okay, so could you please go back to PowerPoint slide number 2? Number two, yeah. In number 2, as we can see, it's based on a YouTube video, and it's not using pure copper, and it does not have a control group. So I understand this is an inspiration of everything. It's not scientific, but is it okay to do that? Sorry, you don't need to answer now. Let me just finish all my questions, please. Okay. So PowerPoint slide number 5 to 8. You mentioned that thermometer and metal plates and glass floor, and we can see there is a at least the thermometer. I actually don't think if you use this type of thermometer, you will not get the actual thermometer inside the solution, because of the solution will corrupt some part of the thermometer to give you a extra heat of the thermometer. So I think maybe you're not getting accurate data. And I'm not sure, the PowerPoint slide 11 is part 1.3. Part 1.3, please. Yes, the selection of materials, as I can see, is not completely covered with oxygenated material of oxygenated metal or completely metal. It's a state between pure and impure. I'm not sure that will work very well. And we can see part 1.4, please. Yeah, we can see the setup is not very laboratory at all, and this part I can see there is no control of the light influx at all. And please, part 1.5. We can see that the entire experiment is conducted under an open environment. I'm not sure that is very cool. Actually, have so many questions, but due to the time we
Could you compile them into a few questions?
Yes, so I will just ask you now. Could you please answer these at first? Thank you.
So, no, can you throw one by one? Because you came up with
One by one, okay. Okay, so first 5 to 8, PowerPoint slide 5 to 8.
about
So thermometer, I am having doubts about this thermometer test results. Are they actually validate enough?
so you're talking if the thermometer was
This kind of thermometer, it cannot accurately measure the core temperature of the solution. It can only measure the surface. So the surface, yeah, I know it's good for comparison, but maybe it's not very suitable when you compare.
About what we actually did was we dipped it in the solution and saw if there's a temperature change, and actually tried to measure if the heat was resulting in the increase in because as you know, heat affects the rate of the current discharge, and yeah, heat was not our main factor as well.
No, I mean you can only test the surface.
No, as you can see, we dipped in a thermometer, so it's actually checking the temperature of the water, not the surface.
No, I don't mean you cannot test the core temperature. I mean you cannot test the reaction heat produced by the reaction.
We are not testing the heat produced by the reaction, we actually
Okay, well, let's move on to PowerPoint slide 11 or what, part 1.3. Selection of metals. I don't think this selection is scientific enough because it's neither covered all with oxygen or covered with no oxygen.
See, if we go back to the video that we took our inspiration from, that
No, the video is not scientific enough. We just discussed it.
something. once you heat the copper plate on a burner like this one, after that black coating is produced, it flakes off automatically. Like because of different heat, like because it has
Okay, I understand. No more questions. No more questions, please.
It has
Please pass it
different
on to
heat,
someone else.
different rates.
Is there any- I understand. So please pass it on to somebody else. Thank you.
Okay, guys. Okay, alright. Well, moving on. I've got another question. I've got a serious question. I just want to know. Obviously, our group is all about efficiency, and we're all sort of wondering. Earlier at the very start, you talked about how this could be a future source of power because it may be better than original solar power cells. I'm just wondering what kind of efficiency, if you did an efficiency, or whether you have an estimate of how efficient your experiment was compared to a regular solar cell. Thank you.
So, as I told you earlier, we actually were experimenting on the same thing. Photoelectrochemical cells as an alternative to solar cells already exist. But what we researched on was that how sunlight, when it hits the electrode, how it can increase its current, not actually comparing it with the original solar cells. So what we decided was to be a better effect was that how we could compare it to the corrosion which was happening. So we could end up in the conclusion that if sunlight is incident on these electrodes or any metal for that example, it obviously corrodes it at a faster rate. So we should cover it. I mean, instead, that was actually a better conclusion than what we thought to be solar, it being an alternative to solar power production.
What we try to say is that initially we aimed this thing to be an alternative, but we ended up finding that it could be, came up with a solution as a result. That covering up could be better.
From the information I've gathered, you guys had a test with the yellow light bulb as well, which for some reason you had thought would be able to simulate the sun's light, however the sun emits white light. But I was wondering what happened to those test results, because in your analysis you had said, I was just wondering if it would have affected the analysis, the conclusion at all.
No, actually, we actually believed that this would have a different effect, but we ended up realizing that it doesn't. So you can see in the later experiments that in the sunlight, we didn't use any artificial light source. Does that answer your question? Any other question?
We have one last.
I'm a student from Stanford, and I'm wondering that where's the slide that has the light? And I'm wondering as how much salt water and the metals used to light up the 21 signal.
We never tried to light it up. It was used as an artificial light source, as you can see in our setup. So, yeah.
So do you think that the result can light up light bulbs? Smaller?
No, it produced current in microamperes, so probably not. In milliamperes. Initially it was in micro, but when you try different combinations, he came up with milliamperes. And so it cannot light. But if we increase the surface area, of course it can. Because that's how we actually, initially as I told you, we were trying to measure it, compare it to the solar cells. So we try to keep the surface area as little as possible so that we can compare it to the solar cells. But then later we realized that we actually ended up finding something else. Thank you.
I would like to go back to this line showing using impure zinc as the anode.
Which one?
And then pure copper anode, impure copper anode. Yes, and then the previous one. Yes, thank you. On the x-axis, you're using different molarity, right? On the right hand side, 1.0 molar.
Yeah.
And you look at 1.0 molar, the yellow line and the red line meet. They match, right?
No, they're not meeting actually. It's they are
very close.
Yeah, they're very close.
Very close.
Yeah.
So the yellow line talking about with light, the red one with no light, right? So from this one, when they're getting closer, it will move on. So you go to 1.2, 1.4, maybe this will work for further investigation. But look at this one, when the concentration getting higher, the effect of light seems
Okay,
not showing significance.
Yeah, I got your question. Actually, as a result, we tried saturated solution, which has the maximum molarity. So that's around 3.6 something, 3.67. So that's the molarity we tried, and over there we found that this was not the result. With light we had better results, and without light we didn't have as good results.
My question is, your theme talking about photochemical cell, right?
Yes.
But when you go to the one changing concentration at some point, the effect of light seems not so significant.
Yeah, that's what I'm saying. When we tried with the saturated solution, the effect of light did seem to be significant again. Yes. Where's the...
Thank you.
Thank you guys.